Problem Introduction. Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode Problem 25, Reverse Nodes in K-Group. This is a classic problem, often appearing in coding interviews, and it's categorized as medium difficulty. The problem statement asks us to reverse the nodes of a linked list in groups of size k. If the number of nodes isn't a multiple of k, the remaining nodes should remain unchanged. So we're not just reversing the entire list, but reversing it in specific chunks. This adds a layer of complexity, making it a great problem for honing your skills. We'll explore different approaches, ultimately landing on an efficient solution. Let's dive in and understand this challenge thoroughly. We'll see how to handle edge cases and ensure our solution is robust and handles various input scenarios gracefully. Understanding with examples. Let's clarify this with a couple of examples. Imagine a linked list, 1, 3, 4, 5. If k is 2, we reverse groups of 2. The result would be 2, 1, 4, 3, 5. See how the pairs are reversed? Now let's consider another example. 1, 2, 3, 4, 5, 6 with k equals 3. Here we'll reverse groups of 3. 3, 2, 1, 6, 5, 4. Notice that the last group, which doesn't have enough nodes to make a full group of 3, is left unchanged. Understanding these examples is crucial before we jump into the code. This illustrates the core logic, highlighting the difference between reversing all nodes and reversing nodes in specific, defined groups. It's all about those k-sized chunks. Brute force approach. A brute force approach might involve iterating through the linked list, repeatedly identifying k-sized groups and reversing each one. This is simple to understand, but incredibly inefficient. Imagine the time complexity. For every group, we might have to traverse it multiple times, leading to a time complexity significantly worse than optimal. Space complexity might not be terrible, but the runtime would be a major bottleneck, especially for large linked lists. We are looking for something much better than this, something that minimizes traversal and operations. Therefore, we'll need a smarter algorithm, and that's what we're going to develop next. Optimal solution. The optimal solution involves a clever iterative approach with pointers. We use 3 pointers: prev, cur, and next. We iterate through the linked list, reversing each k group. We identify the start and end nodes of each k group, and we reverse that section efficiently using the pointers. This strategy ensures only one traversal is done for the entire list, which improves the time efficiency dramatically. It's quite elegant, and we'll see it in action shortly. We can avoid unnecessary memory usage by implementing the reversal in place, which keeps our space complexity remarkably low. The key is managing pointers cleverly during each k-sized group reversal. Code implementation. Let's see the code in Python. We'll start by defining our linked list node class, then we'll implement the reverse k-group function. This function will take the head of the linked list and the group size k as input. We'll use our 3 pointers, prev, cur, and next, to step through, identify, and reverse each k-sized group. I'll add comments throughout the code for clarity, explaining each step. The code is designed to be modular, readable, and easy to follow, so even if you're new to linked lists, this should be quite manageable. Following along with the code and the visuals will help you understand the process of reversing linked list nodes in groups. Edge case analysis. Now let's analyze the time and space complexity. Because we traverse the linked list exactly once, our time complexity is O of n, where n is the number of nodes in the linked list. This is a linear time complexity, which is optimal for this kind of problem. The space complexity is O of 1, because we are using only a constant number of variables regardless of the size of the input. We're not creating any new data structures proportional to the input size. So, both time and space complexities are extremely efficient. Engagement break. So, there you have it, a comprehensive solution to LeetCode Problem 25. Before we wrap up, I'd love to hear your thoughts. Did you find this explanation helpful? If so, please give this video a thumbs up. It really helps the channel grow. Don't forget to subscribe for more LeetCode tutorials, algorithm walkthroughs, and coding interview tips. Also, leave a comment below. Let me know which LeetCode problem you'd like me to cover next. Your support means the world to me. Now, let's finish with a strong conclusion. Conclusion. In this video, we tackled the reverse nodes in K-group problem, understanding the problem, exploring a brute force approach, and then developing an optimal solution with